Hello, welcome to the ninth video of this course. So today we will be discussing about the radius of convergence of power series. So the radius of convergence of the power series So first the definition. So last time I was writing the definition of power series, but it ended in such a way that it's not complete. So let me complete it up. So the radius of convergence of a power series summation an z minus a or n in from 0 to infinity is the unique number are greater or equal to 0, unique non-negative number such that the following two things hold. The series an z minus a power n converges absolutely on the set z in C such that mod of z minus a less than r, which we actually denote by dAr colon r. The disk is centered at a, radius r. And second thing is the series z minus a power n diverges at every point in C minus dAr closure. So let me draw a picture that would make things clear. So here is it. So suppose this is the point A and you are looking at a power series of this form, summation n equal to 0 to infinity a n z minus a to the power n. So you have a number, positive, non-negative number, it can be 0, r, such that inside the disk this converges. Series summation n z minus a power n, this converges, and outside here, all other points in the outside, the series in z minus a power n diverges, and nothing about boundary. It might converge, it might diverge. We'll see that all the situations can occur. Alright? So this number r is the radius of convergence of this power series. Alright. Let's look at few examples. Let's look at this one. let me repeat the example which I did it last time. First example, let's look at the geometric series. I am repeating this example again and again because this is very important in this course especially. So here, what will be the radius of convergence? Oh, maybe before going into that, yeah, so this one we know, converges, this series converges on the unit disk which is Z in C such that mod Z less than 1. This is called the unit disk. And diverges if mod Z is bigger than 1. This implies the radius of convergence of the series summation an z minus a for n. So here an is summation z power n is 1. Alright, what about the general series? So this example is very well known. So what about the general series summation an z to the power n? Well, that one also is done. So here we solved by using Cauchy's root test that the radius of convergence of the series this summation n z to the power n is 1 over alpha, where alpha is lim sup n tends to infinity mod n power 1 over n. Alright, so this we have seen by Cauchy's root test. Right, so the way we argued was informal, but what we proved is if mod z is less than 1 over alpha, then the series converges, and if mod z is greater than 1 over alpha, the series diverges, which is precisely the conditions for that number 1 over alpha to be the radius of convergence. Alright? Okay, so this one will be useful. So consider example 2. Let's look at example 2. Look at the series summation z to the power n by n from 1 to infinity. Let's look at this series. Alright, so what will be the radius of convergence? We'll use this one. So let us look at what is alpha. which is lim sub as n tends to infinity mod an. So an here is 1 over n. 1 over n. So this, what is this? Limit n to the power 1 over n. This goes to 1. As you all know from analysis, a very basic course in analysis. So this alpha will be 1. So 1 over alpha, which is also 1, implies the radius of convergence is 1. Alright. So example 3, you look at this thing, check to the power n by n square, and similarly we get this has radius of convergence one. So this also have radius of convergence. This also has radius of convergence 1. Yeah. Next, look at the series summation. Check to the power n by factorial n. Right? Well, everything can be seen over R as well, which you know already. We'll describe that in a moment. But we look at this one. But this, we want to find alpha. We want to find, so here, in from 0 to infinity with factorial 0, 1, of course. We want alpha, which is lim sub n tends to infinity 1 over factorial n with 1 over n. We have to find such a limit. How do you do it? Yeah, we need to use some certain tricks. So here is an exercise. So that so let n be a sequence of complex numbers. Yeah, and so that lim sub n tends to infinity mod n to the power 1 over n is less or equal to lim sub n tends to infinity mod an plus 1 by mod an. Alright, so you know what is about ratio text. So this is the quantity an plus 1 by an. That quantity comes while using ratio text. But what we actually want is this inequality, and this is true. So hint. So suppose this, if this is gamma, suppose beta is greater or equal to gamma, any positive number, then so that lim sup n tends to infinity mod n to the power 1 over n less or equal to beta for any arbitrary beta which is greater than equal to gamma. Now once you do this, then it's true. Yeah, so this is an exercise to check. Alright, so now we use this one for this series. Here. Let me raise this one. Alright, so now look at here, look at this part, lim sup, so an is 1 over factorial n, so an, since this is positive, we can look at, since all n are positive numbers, so we can look at n plus 1 by n, which is 1 over factorial n plus 1 by 1 over factorial n, which is 1 by n plus 1. The point is you don't need to take lim sup here, as this tends to 0 as n tends to infinity. Alright? So, and this is a positive number, I mean this is also a non-negative numbers, since alpha is greater or equal to 0, this implies alpha is actually equal to 0 by this one, by 1. So this implies the radius of convergence of summation z to the power n by factorial n, which is r is r is infinity. Alright, so 1 over alpha becomes infinity, and you know this, of course, so this converges in whole of C, and we can define e to the power z, the exponential map as summation z to the power n by n factorial n from 0 to infinity, as in the case of real variable. Alright, so the formula of radius of convergence, this one 1 over alpha, this is true for series in real variable. So almost, so if this everything follows from real variable, from power series in real variable. So let me just mention one thing before I stop this one. Comparison about real and complex variable. So in real variable you have a series summation n x minus a or n from 0 to infinity, and a real number, a is also a real number. Alright? And in this case you consider the same thing in z minus a or n from 0 to infinity. So since this R is in C, you look at a n and a all are real number inside complex number, so this also makes sense. So in this case, as I mentioned, you have a disk C centered at A. So suppose this A is a real number, so this is A, and you have a circle disk of radius r where the series converges. And you see, if you restrict this to real line, you get an interval. So here this is a minus r, a minus r to a plus r. So you have this interval as the region of convergence of this series. So this series, the region where it converges corresponds to an interval, and this corresponds to a disk. And the relation, if you look at n is a real number, C, a is also a real number, then you just restrict this to r and you get the same things back. Alright? So this is an important observation. That once you have a pulse series in real line, you can generalize that pulse series to a pulse series in C, where the radius of convergence will be a disk now, and when you restrict the same thing over R, you get back here the same thing. Alright? Thank you.